There are a number of different schemes that are used for this purpose. I like our textbook in the sense that it doesn't go off the deep end either way. It shows 4 generalized kind of reactions, I should say, and 1 or 2 sort of specialized ones. First of all, it recognizes a combination reaction, or sometimes called synthesis, as 2 or more things combining to give 1. A decomposition is the reverse of a combination. 1 thing falls apart to give 2 or more. Okay? There are 2 types of displacement reactions, and I like to illustrate a single displacement reaction like this. Some single substance, X, reacts with YZ to displace the Z, or to displace the Y and form XZ. That's a displacement. X kicks out Y and forms from YZ and forms XZ. A double displacement is like this. It's sometimes called a metathesis reaction. WX plus YZ goes to WZ plus YX. So those are the templates, and your job will be to assign real reactions to these various templates. Now usually, we talked about combustion reactions, for example. Combustion reactions don't necessarily fit perfectly with these 4 general types, so we will consider them separately. Also, if you think about redox, combustion reactions are certainly redox reactions. And each of these 4 may or may not be a redox reaction. And if the question says, is this a decomposition reaction and a redox reaction, perhaps you would be wise to assign the oxidation numbers and check to see whether any of them undergo a change in order to answer one part of the question. So I'm going to look at some examples so that you'll be comfortable with it. The first thing is a combination reactions involving 2 nonmetals to form a binary covalent compound. An example of this is the industrial process that was invented in Germany in the Second World War, called the Haber process, after Fritz Haber, who invented it. It's dinitrogen plus 3 dihydrogen goes to 2 NH3, and you can see 2 substances combine to give 1 substance. Okay? Don't worry about the coefficients. We're just interested in the number of different substances. 2 substances give 1, so this is a combination reaction. Also, we've seen all kinds of nonmetal oxides. Some of them react with oxygen to form compounds with more oxygen or higher oxides. For example, nitrogen monoxide reacts with dioxygen to form nitrogen dioxide. 2 things combine to give 1, so that's a combination reaction as well. Also, metal oxides and nonmetal oxides often react, and when they do, frequently the product is a metal salt of an oxoanion. If we look at lithium oxide and carbon dioxide, those 2 react to form lithium carbonate. Now, let me go back and point out to you that both of these reactions were redox types, because nitrogen went from 0 to -3 in this one, and it went from +2 to +4 in that one. Those are redox. Okay? And the one we just looked at here has no change in the oxidation numbers of any of the atoms that are involved here, so it's not a redox reaction, and that's how we tell. Questions on any of those? Okay, the examples are intended to help you recognize combination reactions here. The reverse of combination reactions are decomposition reactions, which might be generally described as Z goes to X plus Y. The number of substances increases in this process. 1 substance goes to 2 or more substances. Heating certain types of ionic compounds that contain oxoanions is an example of this. You can heat calcium carbonate, lime strongly, and you can form calcium oxide, which is quicklime. This is limestone. This is quicklime, and you can drive off carbon dioxide. One substance produces two substances, so this is a decomposition reaction. Many types of hydroxides and hydrates and some oxo acids release water or maybe oxygen on heating. Copper sulfate pentahydrate, if you heat it, the nice blue color disappears and you get copper sulfate anhydrous over here, and you drive off the water. Some metal oxides decompose to give oxygen, and this is a way to make oxygen in the laboratory. For example, potassium chlorate here, when heated, this triangle, this delta right here means heated. If you take this substance and you heat it, you can drive off oxygen and it leaves potassium chloride here. One substance produces two substances, and therefore that's a decomposition reaction. And you can also see that chlorine goes from +5 to -1, and so that is a redox decomposition reaction as well. Questions on decomposition? Okay. Then let's look at displacement reactions. A very nice way to recognize a displacement reaction that works for all of them that I know of is the number of reactants equals the number of products. If that's the case, then chances are you're dealing with a displacement reaction of one kind or another. And an atom or an ion in a compound is displaced by an atom or an ion of another element. So in a single displacement reaction, as we said, X plus YZ might go to XZ plus Y. And in a double, then it's WX and YZ gives WZ and YX. Single displacement reactions, some examples. If you put sodium in water, you've probably seen the demonstration where the sodium reacts with water to make hydrogen and sodium hydroxide. And some metals react. They don't react much with water, but they react with acid. If you look at this test tube, this metal, the piece of metal that's in there is reacting with acid, hydrochloric acid in this place. The metal is nickel. Nickel reacts with dilute hydrochloric acid to give nickel chloride, which is a nice light green color, and hydrogen gas. And you can see the bubbles coming up here. This is the molecular equation. And if we wanted the total ionic equation, it would look like nickel solid plus 2H plus aqueous plus 2Cl minus aqueous gives nickel 2 plus. This is an ionic compound. And aqueous plus 2 chloride ions, aqueous, plus H2, gas. Well, that's the total ionic equation, but we notice that chloride ions are present on both sides. So we could throw those away because they're what kind of ions? Spectator ions, very good. So the net ionic equation would be nickel plus 2H plus aqueous goes to nickel 2 plus aqueous plus H2 gas. So that would be the net ionic equation. Questions on those? Okay, I'm glad you remember those. Other kinds of displacement reactions are very common in chemistry. A metal can displace another metal from its solution. For example, if we have silver nitrate in aqueous solution and we put a piece of copper in it, a big piece of copper wire in a silver nitrate solution, the silver ion will, the copper solid will displace the silver ion from the solution. That is to say, copper 0 reacts with 2 Ag pluses to produce copper 2 plus plus 2 silver atoms. Now, the experimental evidence for this is shown in the right side. If you let this system sit for a little while, you get beautiful little silver crystals that form on the copper. And a blue color comes into the solution, which is characteristic of copper plus. Copper 2 plus, that is. Copper dication forms a blue color. And so notice this is two substances, produces two substances. So this is a displacement reaction. It's a single displacement reaction because copper is doing the displacing and silver gets displaced. Questions on that? All right. Then we have a few examples for us to work on. Classify each of the following reactions and write a balanced equation. So over here we have, you probably can't see it, but this is ammonium dichromate, this orange stuff right here. And over here in the beaker is some ethyl alcohol. And it is observed that if you heat ammonium dichromate, you should do so very carefully, it decomposes. And ammonium dichromate gives nitrogen gas, chromium-3 oxide, and you'll see this, it's a very dark green color, and I think I mentioned it before, it is the primary coloring agent for American paper currency. Very stable green solid. And then we get water. So let me see if we have any sound here.
The ammonium dichromate volcano illustrates what happens in a chemical reaction. The orange solid is ammonium dichromate. When a wick soaked in alcohol is placed into the ammonium dichromate and ignited with a match, the higher temperature causes the ammonium dichromate to start reacting. The darker material which is forming is evidence of a chemical change. As the reaction proceeds, it generates heat and the dark solid material is formed more rapidly. Flames and sparks can be seen shooting upward. The orange solid has been transformed into a dark gray-green solid and the temperature has changed. These observations are characteristic of a chemical reaction. A substance with one set of properties is transformed into one or more new substances with a temperature change.
Okay, so the green solid is a chromium-3 oxide, and you could see it sort of bubbling up there from the gas that's produced, which is partly water vapor and partly nitrogen. Now, we used to always do this little decomposition reaction until we got 2 reports of students being hurt when it exploded. So you're going to have to settle for video here. I'm sorry, I don't want any of my students hurt from anything that I do. So decomposition, one substance produces 3. And here's the balanced chemical equation. You can use that to practice balancing equations if you'd like to. So that's the first one. Here's another one. If you heat magnesium and dinitrogen, you produce a red solid, which is magnesium nitride that we talked about once before. This is a combination reaction. 2 substances produce 1. And it is the reverse of the next one, which is hydrogen peroxide, which spontaneously decomposes in the presence of light to water and oxygen. And here's the balanced chemical equation for it. And that is the reason why most hydrogen peroxide solutions are sold in brown bottles. Now, I noticed that Crest, the toothpaste company, is selling a hydrogen peroxide rinse for brightening your teeth. And they don't put it in a brown bottle, but they do put it in a completely opaque white bottle. After I used it all, I held it up and looked in there, and it's very dark. So evidently it doesn't have to be a brown bottle. A white bottle will do, provided that it's completely opaque. The decomposition is one substance produces two. Finally, aluminum reacts with a lead-2 nitrate solution to make aluminum nitrate. There was an error in the notes right there. I think it just said nitrate. I'm not sure. But if yours just says nitrate, write in aluminum right there for me, will you please? And lead. So here is the balanced chemical equation for it. And you notice that two substances produce two substances, and therefore this is a displacement reaction. Is it single or double? It is single. It is single. Okay, I remind you that section 4.7 on reversible reactions is not going to be covered in our course. That will be put off until Chem 2. And that'll be the end of chapter 4.